Continuing on from last day, been looking at inclines. We said the key idea here is you have to break up gravity into its components. You have to break gravity up into horizontal or parallel and perpendicular. So we're continuing from where we left off last day. You with me? You got lesson 6 from last day? You with me? As I told you to get out the lesson from last day, the last question from the lesson from last day. So I'm starting. I like this question, I like this question, I like this question. This is a nice question. Now I got your attention. So example 8 says, consider a 6 kilogram mass sliding up a rough 32-degree ramp with an initial speed of 20 meters per second. I better dulp here a little bit. So I'm going to draw, there's the ramp. The angle, it says, is 32 degrees. Here's our mass. And if I hadn't already underlined, I would underline, okay, it's sliding up. Someone gave it a push, Courtney, and then let go. I think if it's sliding up the hill, it's clearly going to come to a stop pretty quickly. Because when I push things up a hill, they don't keep going. And this is not on wheels. This is sliding, so it's going to come to a stop really quickly. That's okay. A says find the force of friction. B says find the acceleration. C says find the time to stop. D asks how far up the slope the mass travels before stopping. All right, I think I'm going to start out by labeling my forces. What are the forces acting on this block? Get the obvious ones. Gravity down? Absolutely. mg. Which we are going to break up into a parallel and perpendicular component in a second. What else? Normal force. By the way, I'm kind of imagining that my perpendicular component's going to be about that long. Let me erase that just so I don't gum up my diagram. So, and I know normal force is the same size in this diagram as the perpendicular, so I'm going to eyeball it. Normal force is going to be about like that-ish, give or take. What else? Friction. Which way? Which way is the block sliding? Up. So parallel down. Friction. Okay, attention span over here, folks. I'm sorry, but this is important. Deal with the distraction. Or I'll park it in the alcove out of the way. Oh, components. Let's break this guy up into mg perpendicular and mg parallel. And you had a dumb way to remember this. What was your dumb way to remember that? I think it was you.
2 lines is sine.
2 lines is sine? Oh, okay. There's his way for the parallel symbol. Now you have to remember the difference between perpendicular and parallel, but I'm kind of hoping in grade 12 you figured that one out. Anyhow, A says, find the force of friction on the mass. Okay. A. Friction is mu times the normal force, always. Do I know mu? Yep. I don't know the normal force. Oh, but look at my diagram. I know another force exactly the same size as the normal force. Which one? Don't you dare say mg. Which one? Dylan. Ah, so if I hear you, you're saying it's going to be mu mg perpendicular. We're going to have to do a little trig. Oh, remember we said, Dylan, if we always draw the perpendicular component followed by the parallel component, then this 32 degrees is also going to end up, come on, pen, running slow. This angle ends up right up here. Don't. Draw it my way. What happens if I make it tougher, Mr. Dewick, and increase my chances of, go ahead, I guess. Increase my chances of making a mistake. Go ahead. mg down, you could go parallel first and then perpendicular, in which case it's down there, and that's also fine. I'm just saying let's make all of our diagrams look the same, and the 90-degree angle is up there. I don't want to do it that way. Sorry, I thought you were asking, hey, what if I just ignore your advice? I was like, okay, I've got 16 years of teaching. I think my advice is pretty good, but okay. Adjacent, opposite, hypotenuse. MG perpendicular is adjacent. From last day, do you remember which trig function did that end up being? And show it was a fairly nice substitution. It ended up being, the mu still stayed there. MG perpendicular got replaced with MG cos. Okay, we can plug in numbers now. 0.1, M6, G 9.8, cos 32. What is the force of friction? Ah, the sound of people getting out their calculators. The sound I love, although it's nicer if it's done before the tone in this class. What do you get? It's funner when you do the math, Mr. Duke. No, you need to practice this. What do you get? 5.0? Anyone else? Bus driver's right? 5.0 even or 5 point what? 4.98? 4.98 what? 4.99? Let's go to 3 sig figs is really what I'm trying to draw you into here as opposed to 5.0. Let's go 4.99. Units. Newtons. It's force. B. Find the acceleration. Okay. Who's winning? Zach, Mr. Bus Driver. What? Friction and gravity. No loser, 2 winners. See it? Friction and gravity are what are causing this to slow down. So I'm going to go like this. And by the way, technically not mg gravity. Which gravity? Mg parallel. Okay? My equation is going to look like this. Winner number 1 plus winner number 2, that equals MA. Not winner minus loser, Nico, winner plus winner. Okay. What was mg parallel? 2 lines was what? Oh, that's not bad. So you're saying this is mg sine 32. And I'm not going to plug in the number for friction. I'm just going to plug in the expression, which we said was mu mg cos 32. I'm just plugging in that guy right there, but I don't want that big arrow in the way. Equals ma. And there's a reason I did this. Let me see it. Turns out, since there's a mass in every single term, the masses cancel, which means the a is already by itself. I guess the acceleration is going to be g sine 32 plus mu g cos 32. Cool. I guess the acceleration is going to be 9.8 sine 32 plus 0.1, 9.8 cos 32. What do you get? And this one I'm going to do because I want this number on my calculator for later, I think. 9.8 sine 32 plus 0.1 times 9.8 cos 32. Do you get 6.02 for that thing? So I'll go 6.02, but I'll keep this number on my calculator. Units. Meters per second squared. C. Britt, what's C asking us to find? Time. You know what? Now we're back to unit 1. I'm going to defic. I'm going to say t equals question mark. What else do I know? Oh, what's VI? What else do I know? VF is what? Oh, stop. What else do I know? Oh, is that why they had me? So I would have no problem giving you this question, but actually not walking you through part A and not walking you through part B. In fact, not even walking you through part C, going straight to part D and saying, hey, I think you better clue in that you need to find all this stuff to find it. Okay? What was the acceleration? 6.02 is wrong. That's wrong. My calculator number is wrong as well. What? Okay, now we're back to Unit 1 show. We are slowing down. Yes, we better call this a negative acceleration. We got away from putting in the negatives because in our winner minus loser, when we have stuff, especially on the Atwood machine, moving in more than one direction, it was just too confusing to keep track of. We said, let the winner be positive. But now we're back to Unit 1. It is slowing down. I better say that's a negative acceleration. I'm looking for an equation that has t, vi, vf, and a in it.
Can we give like just a regular acceleration if it just asks for acceleration? Should we rate that as a negative?
No. I'm good with that. Oh, and by the way, if you'd missed that, you would have noticed because you would have got a negative time and you would have freaked out a little. Hopefully, Courtney, you would have said, well, time isn't negative. I know I saw the Star Trek episode. No, time isn't negative, right? Which equation? Which equation? Can you get the t by itself already? Yeah, t is going to be good old vf minus vi all over a. It's going to be 0 minus 20. The top works out to be negative. So that's why you need a negative on the bottom so that you get a positive time. And now I am going to use the value on my calculator. So I'm going to go 0 minus 20, close bracket, divided by negative button, and then my answer button. That works. And I get a time of 3.32 seconds. So it's going to slide for almost 3.5 seconds, slowing down the whole time, and then come to a stop. I wonder how far it'll slide. That would make a good part D. Is that what I asked, part D? How far? Oh, sure. D. How far will it slide? We've listed our data in C, so Nico, I'm not going to read DFIC. I got my C stuff here. But I'm going to write, just to remind myself, D equals question mark. I'm looking for an equation that has D, VI, VFA. I'll use T if I have to, but if there's one that doesn't use T, I'll hedge my bets and use that one. Is there? Is there? VF squared. Can you get the D by itself, please?
VF squared minus VI squared over 2A.
VF 0 squared minus VI 20 squared all over 2 times negative 6.02. I have to include the negative again, and I noticed that because I could see the top was going to be negative, and I'm pretty sure we're traveling forwards. I do want a positive answer, right? More than one number on the top. Bracket 0 squared. I guess I could have skipped the squared on the 0 because, oh well. 20 squared divided by bracket 2 times negative 6.02. How far will it slide for? You get 33.2? 33.2 meters. Yes? No? Sebastian, am I right? Yeah? So as part of your homework to the homework from last day, I think now we can certainly say number 5. I think I can also add number 8. Now, when it says find the force equations, what that's really saying is write an equation. Your equation will look a little bit different from the answer there. Although maybe not. Well, we'll see. But certainly you can find friction, acceleration, and time to stop. Ooh, number 9. They're telling you how far it travels for. If you know how far it travels for, I think you can find its acceleration. And once you know its acceleration, find the coefficient of friction that caused it. So you're still going to be doing almost the same thing here, except you're going to end up solving for this bad boy, given that you know this bad boy. Okay, nice twist. 10, nah. 11, nah. Did already. 12, I'd like to find the angle, but that's a bit yucky. No, we're good. Lesson 7, advanced inclines. So this is the next one I handed out. This would be the second handout that I gave you today. Now we're moving on to that. Well, you know, apparently you need it. You are so good to be his friend. All right. Let's kick it up a notch. You guys are really fascinated by that school bus back there. It seems like you're staring out there. You okay? No, I'm talking to Cami. You're good? What? Yeah. Nothing? Okay. How much force is required to pull this mass up the frictionless ramp at a constant speed? What's the key word or key phrase that you would probably underline in this question to say, hey, this is telling me something important? Frictionless is one. There's another phrase. Yeah. Because what does that tell me? As a number, what does that tell me then? Shashan? I'm going to make it a little note here. A equals 0. I'll even put an exclamation mark so it keeps my attention. Yeah. Okay. All right. I've never seen this question before. I think we can handle this, though. How am I going to start this, do you think? Label my forces. What are the forces acting on this block? Get the obvious ones. Yoink. mg down. By the way, you notice I always draw mg pretty big. It's because I want a nice big triangle to be able to draw stuff in. I found the kids that go like this, the kids that go mg, and then they try and go parallel, perpendicular, always make mistakes because it's not as obvious what's perpendicular and what's parallel from something that size. So this is one time when I'm going to say to you, hey, exaggerate, make mg big. You can draw the rest to scale and just draw a big diagram. So mg down. And Cole, I think I heard you murmur normal force. I agree. And we would break this into its components, yes? Here's good old mg perpendicular and mg parallel. 2 lines is sine. I'm going to use that for the next, well, good gosh, 21 years apparently I'm still teaching for. You're glad? Yeah, me too. What other forces? We're missing one, I think. Because, by the way, if this was it, we have an unbalanced force pulling it down the hill. It would have to be sliding down the hill, and this question says it ain't. Alondra, you're right. Tension. Good call. There's a rope. So, tension. Friction? Nope. Could I add friction? It would be a tougher question, but sure. If we were sliding up, friction would be down the hill. I'd have one extra force. Oh, and that would be mu times the normal force. I don't know the normal force. It would be mu mg perpendicular. It would be mu mg cos. I could deal with it. Who's winning? It's a trick question. It's a tie. How do I know it's a tie, Shashan? What did you say earlier? Acceleration is 0. Since it's traveling up, just so I can wrap my brain around it, I'll let tension be the winner since it is moving up. Why make it tougher and let gravity be the winner and have it moving in the opposite direction up? So I'll let tension be the winner. So I'm going to write my equation. Everything pointing up the hill is winning, which means what's pointing down the hill? Don't say mg. What's pointing down the hill? Mg parallel. What does that equal, Sebastian? But what's 0? What's A? Sorry, what's A? So it equals what, grand total? I know. 0. You know what? I'm just going to plus the mg perpendicular or parallel over to the side, I'm going to say those two are equal. And if you did that in one step, if you had just clued in, hey, those are the only two forces on the hill and they're in opposite directions and it says constants, they're equal. Holy smokes, this question looked really tough, but I think I'm going to get there in 3 lines. Because what is mg 2 lines? Holy smokes, I'm going to get there in 1 line. Because now it's plug and chug. Do I know the mass? It's on the diagram. Does the mass cancel this time? No. It's going to be 7 times 9.8 times the sine of 40. Oh, this is great! Advanced inclines. Bring him on, Mr. Dewick. A couple of lines and I'm good. What do we get? 44.1. Anybody else? No? Yeah? Units. Units. Newtons, tension, right? Okay. Hey, could I change this question by actually making it accelerate so it wasn't equal to 0? Could you still find tension? Yeah, you'd instead of equals 0, be equals ma, and you'd plus the mg parallel over to the other side. Oh, could I include friction? Sure. I mean, it'd be tougher in that it would be longer and more stuff to keep track of. I don't think it would be tougher in that I'd really have to be wrap my brain around stuff. I'd just be more careful when I was labeling things. Suppose mu equals 0.65. How much force is required now? Friction. Which way would friction be pointing? Oh, you don't have B on there? Oh. That was odd of me. Okay, if I had included, you got room? Well, I write down B. So add B. There's room. 0.65. Halfway between 0.63 and 0.64 and 0.66. Well, 0.63 and 0.67, halfway between there. Good recovery, Mr. Dewick. Now I think you can count again. What would the change be to my free body diagram? What other force would I add on here? Friction. Which way? Down the hill. I got to be fussy because I'm worried if you say down, you mean straight down. Let's call it down the ramp. And then I know you're talking a parallel. Yes? And up the ramp. So down the ramp. So it would be a loser. We would have this. Winner minus, okay, gravity is tugging down and friction is tugging down. That equals, it's still a constant speed, still 0. In fact, our equation would modify to being mg parallel plus friction. That's what tension has to cancel out. And since we already got tension by itself, and we already said mg parallel was mg sine 40 plus friction is mu times the normal force. Nope! I don't know the normal force. Oh, but look. I know another force the same size as the normal force. What? Perpendicular component of gravity, which was, if 2 lines were sine, what was the perpendicular? So if I hear you, think about this. We're doing this in like 3 lines. This is pretty good. You're telling me it's mg sine 40 plus, don't forget the mu, mg cos 40. Well, now this is just plug and chug. The mass was 7, g, good old 9.8, sine 40 plus 0.65, 9.8. Oh, I forgot the mass, Mr. Dewick. 0.65 times 7 times 9.8 cos 40. And by the way, you'll notice the masses don't cancel here. Sebastian, I do have a mass here and a mass here, but I don't have a mass in the tension, so m's don't cancel. Don't get cancel happy. All right, now what's the tension? Yo.
This wasn't physical imaginary world, and the tension in the rope did have mass. Would there be mass involved with it?
If the rope had mass,
Yeah.
would we have to factor that in? Yeah, it really depends on how long your rope is. So if you're a rock climber and you're maybe paying out 10 feet of rope, probably pretty irrelevant because that maybe weighs a few ounces. If you're paying out 150 feet of rope, then that rope tension is taking the mass of the climber, but the mass of the rope is not insubstantial. It's also having to include that as well. It's a very famous calculus-related rate problem. If you have a rope that's slowly extending over a cliff so that the rope keeps flowing, that means you actually have a mass that's changing, which means now you have a really difficult force question because if F equals ma, here we don't have a changing A is still 9.8. What we do have is a changing M. What do you do now? Yep, that's a famous one. What do we get? Good question. And I used to know how to solve it. I think it's... how you solve that one. It's an integral. Those are integrals. Who's in calc? Preview coming attractions. But you won't get to that till about April. Sorry, what do we get? 78.3. Anybody else? I know it's bigger. If I got an answer less than 44, I'd make a calculator mistake, obviously. All right. Woo! Look at this. I'm going to argue you set this up right, and you know what? It's not too bad. Two objects are connected as shown. If this thing is going to slide, can it possibly slide to the left? There's no outside forces. Can it possibly slide to... If it's going to slide at all, it's going to slide down the hill towards the right. Although it's possible friction is so big that M2 hasn't got enough mass to pull it down the hill. It's possible. How will I know that? If I get a negative acceleration. I'm going to assume that M2 is winning. And if I'm wrong, I'll get a negative acceleration and my bets are off. Okay? Let's label my forces. Oh, by the way, M2 frictionless, so no mu on M2. M1 does have friction. So I guess the ramp is made out of ice, but the level part is gravel. I don't know. What are the forces acting on M1? Get the obvious one. M1G. Oh, and we'll have a normal force. And I'll call it normal force number 1. And this one, the normal force is equal to mg. We're not on a slant. What else? Which way? I think to the left. Gianluca, you okay back there? Just making sure. What else? Tension. Is it flat? Then we're good. It's in the same direction as gravity, right? Which one will be breaking up into components? M2, which is going to have mg. Normal force number 2. What else? Yeah, tension, definitely. And we will break this up into its components. We will say, hey, this is M2G perpendicular, and this is M2G parallel. And I should have put a 2 on my mg over here, just to be careful. Here is the key question. If you get this, the question falls apart. Who's winning? Sebastian. That's what's pulling everything down the hill. If it's winning. Might not be. But if it's moving, it's because of the parallel component of gravity, because that's what's in the same direction as I think M2 is accelerating. So I'm going to have anything that ends up pointing down the hill this way be winner. Anything that ends up pointing up the hill, loser. Why do you always look at me when you say that? Sorry, grade. M2G parallel. Let's walk along the rope. Oh, I run into a tension. This one right here, winner or loser? Loser. So minus. Oh, I run into another tension. Winner. Oh, and then I also have one more force in the same direction as the rope. Friction 1. Loser, winner, loser. What's the right-hand side going to be? Yeah, M both of it, right? M1 plus M2. Have I looked at more than one mass in my equation on the left? I better include more than one mass on my equation on the right. M1 plus M2 times A. Oh, Mr. Dewitt gets to relax again. This is just too good. Tension gone. How would I get the A by itself? Divide. Oh, and here the masses don't cancel. There's not a mass in everything right now, sadly. So if I hear you correctly, you're saying A is going to be M2G. What did you tell me 2 lines was? Sine 42 minus friction is what times what? So this is going to be mu normal force 1 all divided by M1 plus M2. M2, I've scrolled down. How big was M2? Thanks for your help. 9.8? Oh, why did I use 9.8? That's going to confuse you with the other 9.8. Anyways, 9.8 times 9.8 sine 42 minus, what was mu, 0.17? Times the normal force. Rats, I don't know the normal force. Oh, but look. I know another force the same size as the normal force on mass 1. Which one? M1G, and M1 was 12 times 9.8, all divided by 12 plus 9.8. Carefully, this one you probably want to try on your calculator, all of you. You got more than one number on the top with some trig and more than one number on the bottom. You might want to make sure you know how to type this in. I'll give you a hint. Brackets on the top, brackets on the bottom, bracket. 9.8 times 9.8 times sine 42, close off the bracket, minus 0.17 times 12 times 9.8, close off the top bracket, divided by, close bracket, 12 plus 9.8, close bracket. I think you get 2.03, not 63 point something, 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 something. Double check. Am I right? By the way, cool. If this was in free fall, what would the acceleration be? You know, if this was in free fall, what would the free fall? What would the acceleration be? 9.8. Are we slanty? Can we possibly be falling faster than 9.8 if we're slanty? So I would call your guess, I would say, bad guess. I already knew ahead of time. There's no way this answer is bigger than 9.8 because you can't fall faster than gravity, especially if you're not going in a straight line with gravity. Which is nice. I mean, it gets rid of a lot of wrong answers. But you better figure out what you did wrong. Is 2.03 right? It is. B, find the tension. Okay. Which mass is going to be the nicest one with which to find the tension? Mass 1 or mass 2? They both work. Which one would you prefer to find the tension with? Mass 1 or mass 2? I think mass 1, way less gunk on it, and it's level. Mass 1, who's winning? tension. Who's losing? Oh, so mass 1, your equation is going to be tension minus friction equals M1A, because now we're just looking at one mass. Tension is going to be M1A plus friction. It's going to be M1A plus mu times the normal force. I don't know the normal. Oh, wait a minute. For mass 1, the normal force was a lovely Emily M1G. Yes? M1 was 9.8 or 12? 12. Times 2.03 plus 0.17 times 12 times 9.8. 12 times my previous answer plus 0.17 times 12 times 9.8. What'd you get?
44.3.
Let's see, 44.3. I got 44.4 using the whole, yeah, I'd take 44.3. 44.4. Units, newtons. The theme, Sam, for these advanced inclines is, you know what, as long as you're careful with your labeling, I guess I can make it tougher, but really what I'm doing is making the question longer, more lines, a few more expressions. Next page. All right. How would you figure out which way this system moves? Okay, but so Sebastian in the back corner said, well, big M, I'm assuming it's a bigger weight, probably. But it's at an angle, so it's not pulling straight down. This is a tougher question. Now, there is one way. The first way is make a guess, and if you get a negative acceleration, what? You guessed wrong, quickly go back and make your winners losers, your losers winners. You might have to flip a friction. And I'll be honest, that is my preferred method because I'm interested in saving time. And it's a pretty easy fix if I get a negative acceleration. However, we can actually give you a definitive answer. What are the forces acting on that little m? Get the obvious ones. We'll call that little mg, tension. Normal force on little m? No, it's hanging in midair. What are the forces acting on the big M? Get the obvious ones. Normal force. And we would break gravity up into big mg perpendicular and big mg parallel. Can you see which two forces are really in a tug of war with each other? Little mg and, I heard someone say it here, and big mg parallel. Whichever one of those is bigger, that's what's going to determine which way it's going to move. And now that we have Cole's little trick of 2 lines equals sine, actually, in 5 seconds, you could probably quickly go to your calculator and crunch the numbers and see who the winner was. You would go little m times g equals. You would go big M times g times sine equals. Whichever one is bigger is the winner. Yeah. Yeah. But what do we know in the main equation will happen to the tensions? They cancel. And the question was simply saying, how would you determine the direction this system moves? Whichever is larger between little mg and mg parallel, which is big mg sine. Can you survive without that? Absolutely. You just get a negative acceleration. I did one a couple of days ago where we guessed wrong. I did that on purpose because you saw it was a pretty quick fix, Courtney. It was changing a couple of minuses to pluses, a couple of pluses to minuses, big whoop. But at the same time, I'm a nerd. I kind of like to know ahead of time.
Do you like if that was the question on the test and you got the negative acceleration? Can
No, I would expect you to go back and correct things really quickly. Yep. Example 3, this is fair game for your test. This is about as tough as we'll get at you. Well, I have seen occasionally as a multiple choice question 2 ramps. Something like this here, number 3. I'm going to give you one to try for homework. I have seen that before too. Not as a written, but as a, here's a nasty multiple choice. Oh, okay, you've got different sines and different cosines in your equation, but it's still going to be mg cos and mg sine for your perpendicular and parallel components. Big whoop. Find the acceleration of this system. Okay. Let's try and, ooh, this one has friction as well. Here, it's worth figuring out who's winning ahead of time, because if we guess wrong, we would have friction pointing in the wrong direction, and we would have to flip that around too. So what did we just say? This is a contest between 5 times 9.8. That's what's pulling down on the left. What's pulling down the hill on the right? 8 times 9.8 times parallel 2 lines is sine, 30. Who's winning? Which way is this, the big mass on the hill? Is it going to be going up the hill, or is it going to be sliding down the hill? It's going to be sliding up the hill now. I've got my direction for friction. Now I know. Let's label my forces. What are the forces acting on the left-hand mass? We're going to have M1G, tension. What are the forces acting on the right-hand mass? We're going to have, yoink, M2G. There is going to be a normal force. Tension pulling it up. Oh, since I know it's sliding up, I know that friction is sliding it down. And let's break this up into M2G perpendicular, M2G parallel, where this angle and this angle are the same one. Do you guys want to try this on your own? I'll just do it silently up here, and let's see if we end up in the same spot. If you get this, you're in actually pretty good shape for the unit test. This is about as tough as I'll throw at you on the written. Let's see, it's going to be I mean, you can look up if you need to, but see if you can get all the way there yourself. M2, Mr. Duke. Keep your masses straight. Yeah, I got. Okay. Oh, when you're done that, find tension. There's one mass that's clearly easier to use to find the tension with than the other. So find the tension while you're at it. Do you get? I got an acceleration of 0.493. Phew. It's a little worried. Actually, I figured the acceleration would be pretty close to 0 because I don't know if you remember when we crunched mg and then we did m2g sine. One was 49 and the other one was like 39.2. They're almost the same. I said, you know what? There's not much unbalanced force here, especially with friction in the picture. What was M1? Yeah? Ah, you got caught by Math 8, right? Who's winning? M1G is winning on the left-hand side, yes? So I said, okay, M1G is winning, minus tension. I'm going to plus the tension to this side. At the same time, I'm going to minus this over to the other side, right? Which is why I usually tried to let tension be winner, but if I wanted tension to be the winner, I would have had a way more complicated term over here. Ugh. I would have had M2G parallel. I would have had friction. Ugh. Forget that. Is that okay? How many got that right? Nice. Good. Turn the page. The only other thing, and I think this is the last one I'm doing. Yep, last one. The only other thing I can do now, Emily, is make you go backwards. What if I give you the acceleration and I don't give you one of the masses? Oh, you guys don't have this one either?
We have the writing. But
You have the writing? Okay.
also,
Oh, what does yours say?
at the top of a hill, an 84 kilogram skier has an initial speed down the hill of 5.8.
Wow. What lesson did I print here, Mr. Dewick? Now I'm a little worried here. Hang on. Bear with me for a moment. Let's pause the lesson. Cross out the one that you have and copy this one out. There, we're going old school. I'm actually making you write out a question. Don't you feel like 10 years ago? This is what drove me crazy when I was first teaching physics. The fact that I would throw a question on the board and then I'd have to wait for 10 minutes while the kids were carefully copying it out. I was, oh, what a waste of time, which is one of the reasons I went to this method. I think I can do this. Hang on. Okay, I can't get much bigger than that at Chemi, but hopefully that helps. You know what? I would draw the picture first. If you want to shorten this, if you draw the picture, but instead of M1, put an 8 there. Instead of M2, put a question mark, or put an M2 there, because that's the mystery mass. And then if you want to, somewhere off in the margin, you can write A equals 2.1 with an arrow pointing upwards. Mu equals, whatever you need to. You can write it out if you want to. But well, while you guys are doing that, I'm going to delete the wrong lesson 7. Nuke. File, save as, a PDF, save. Do I want to save the changes I made? Sure I do. Oh. Let me know when you're ready. This is the last one. Okay. Oh, by the way, no magic. I guess that should be attached there with the pulley. Just kind of hovering in midair. Any of you tried doing graphics in Microsoft Word at all? Like, these take just ages. My friend is the master of the stick figures, and so that's why the graphics you've been getting all year are those wonderful stick figures. They're great, but to retype those, I'm just not looking forward to it. Otherwise, it's a terrific resource. We're good? Hey, what are the forces acting on M1? Get the obvious one. Okay. What else? Tension. M2. We have M2G. Normal force. Tension pulling it up. And I think it's accelerating up, so friction would be slowing it down. It does mention friction in the question. Yes, it does mention a mu. Oh, isn't accelerating M1 accelerating up? I stand corrected. So friction is in the wrong direction, Mr. Dewick. Thank you. Read the question. So you're saying friction is this way. Okay. Cool. Yeah, candy for you later. What do they want me to find first? Which one's going to be easier, do you think, to try and tackle for tension? Let's try and write an equation and see what happens there. Let's see. We have, who's winning in mass 1? If it's accelerating upwards, winner minus loser equals M1A. Do I know M1? Check. Do I know G? Check. Did they give me A? Okay, then this one's going to fall apart pretty quickly. Zach, you're just going to plus it over. Make sure you don't botch it. What was M1? 8 times 2.1. 8 times 9.8. 10.9 times 8 is going to be 80 plus 7. Is it 87.2? Oh, I'm way off. What? 95.2. Wow. Bad math, Mr. Dewick. Okay. B, what do you want me to find? You know what? We should break this up into its components over here. We didn't do that, did we? We got mass 2 perpendicular and mass 2 parallel. I don't know mass 2. I guess what I should try doing is writing a mass 2 equation. I think. Oh. So, what are the forces acting on mass 2? Just on mass 2. Who's winning? Mg parallel. Who's losing? Friction and tension. Okay, let's try writing that and see what happens. So we're going to have M2G parallel minus friction minus tension equals M2A. Yo.
How do you have M2G parallel winning? Is it going to the left? No?
Is this going up?
Oh, that's going up. Never mind.
Right? That's what it said. I don't worry, I did the same thing. Sebastian corrected me too. You okay with that so far? Let's simplify. So parallel, you said 2 lines was, so this is going to be M2G sine. What was the angle? Didn't give you an angle. Do we need an angle? I think we do, Mr. Dewick. Sure. 30 degrees. Will you have to ever find an angle on the test? That's not part of Physics 12. I would consider that, I think there's one in the scholarship section questions on your big review that asks you to. No, but you'd go shift sine or shift cos or shift whatever. So sine 30 minus friction is mu times the normal force. Rats, I don't know the normal force. Oh, that's going to be mu m2g perpendicular minus tension equals m2a. Oh, just hang on. Cole's saying divide by A. Since I have so many M2s, and that's what I'm trying to find, I'm going to target those. I don't care about the A right now yet. I'm probably going to end up getting all the M2s to the same side, but let's get rid of this perpendicular. This is going to be M2G sine 30 minus mu M2G cos 30 minus tension equals M2A. Let's get all the M2s to one side and anything that doesn't have an M2 to the other side. I think, Brett, what I'm going to plus the tension over, and I'm going to minus the M2A over to the left side. I'm going to go move this guy to here, move this guy to here, and I got all my M's on the one side at least. With me so far? I'm missing a C in there somewhere, Mr. Dewick. So far, so good? Anybody know how we can get the M2 by itself fairly easily? My math 12s should remember this trick. What? Holy smokes, I never taught you in math 12 and you came up with it right away. Factor what? There's an M2 GCF on the left-hand side. Is there an M2 in every term? Factor it out. We'll get this. M2 bracket G sine 30 minus mu G cos 30 minus A. Who'd you have for math last year? I'm impressed. I need to compliment him, because I usually have to coax this out. Why is this so nice? By factoring out the GCF, see the M2 sitting in the front all by itself? How would I get it by itself? What's happening between the M2 and that big bracket? Multiplying, so how would I get it by itself? Divide by what? The big, huge bracket. Which is ugly, but I got a calculator. M2 is going to be the tension, which we figured out in part A, yes? Divided by G sine 30 minus mu G cos 30. Conveniently, I still have the tension stored on my calculator. Woohoo! Oh, minus A. Thank you. Sheesh. Sloppy. Tension was 46.5364. Yeah? 95.2. Oh, you guys did the tension for me. That's right. 95.2 divided by bracket. I better scroll down a little bit here. G 9.8 sine 30 minus, what was mu? 0.12. G cos 30 minus, A was 2.1. Hope that works. 53.4 kilograms. Yes? No? Yeah. That's, this would be fair game as a nasty multiple choice question, but not as written. 2.1 from the question, right? What's your homework? Absolutely, number 1 is fair game as a nasty written question on your test. I won't put 10 of those, but number 1 is fair game. What do you think about number 2? Yeah, number 2 is homework, but like, nice one to think about. Try 3. So 1, 2, 3. And 8. 1, 2, 3, and 8. That's plenty.